third degree polynomial, and we know that it's third degree, so basically the fundamental theorem of algebra says if it's the power of 3, that means it tells me the types of zeros. The question is it going to be real or imaginary? This number in yellow is a real, and here this one is an imaginary because it has an I in it. We learned that the complex numbers come in pairs. The conjugate of positive I is a negative I. So this is like 0 plus I in the form of a plus bi, and then negative I. So there's my 2. So basically the fundamental theorem of algebra kind of gives us a hint of how many. Yesterday we did a substitution of all those numbers in, and we multiplied these two binomials, and we got this. Now, inside the box, none of these are like terms. Although these both have an x, this one has an xi and this one does not, so they're not like terms. Count with me. Ready, set, go. I now need to create a box that is 4 by 2. Let's do that. 4 by 2. It doesn't matter if your box is long like mine or this direction. Does not matter. I'm going to go ahead and write these numbers here. X squared, 3x, negative xi, and minus 3i. Yesterday we were putting little checks above the problems to help us make sure that we account for all of them. So basically we're doing this right now. We're multiplying this polynomial times this binomial. So I'm going to put x plus bi on the top here. And again, if you're kind of lost of what we were doing yesterday with this box, it's multiplying, and then you're going to add. And this is the reason why FOIL does not work. The reason why FOIL doesn't work is if you're using FOIL in this problem, you would basically have to distribute the x to each of these terms, distribute an I to each of those terms, and then combine like terms, which is essentially the same thing we're doing here, but it's a little bit more organized in a table. And they call this the area model. Class x times x, x squared times I, x squared I, x times 3x, 3x times I, x times negative xi squared, I times negative xi, negative 3i times x. Remember, whatever order you picked, if you wrote I then x, or it's preferable that's x then the I, just be consistent so you can see the like terms. Class, negative 3i times positive I? Negative 3i squared. Okay, so our answer we're going to put up here. I'll put in blue. Let's now combine like terms. And I like to put a check or some kind of mark in each of the boxes to account for. Class, is there anything that has an x cubed? No, so let's write that. X cubed. Okay, this one has an x squared. Remember, this one's different from this one. Are there any ones that have just an x and a power of 2? So that would be 3x squared. Check mark. Okay, are there any other boxes that have x and an I? So positive 3 and a negative 3 equals 0. Canceling in this problem equals 0xi. You'll notice again that these are opposites, negative 1 and a positive 1. Class, I squared is equal to negative 1. So that's a negative 1 times negative x, which is what? positive x. There are no others that have an x, so I'm going to write the x here. Negative 1 times negative 3, positive 3. And this is our answer. Great thing about math is that there are multiple ways of doing this problem. So I'm going to call this one method number 1. And I'm going to show you guys a second method. And you get to pick which method you like better, because it does not matter, because you'll see that we get the same answer. Let me show you guys how to do a second method, or a second way of doing the problem. I'm going to copy the problem from here. So I have just kidding, I can't do it on this problem. Scratch. That means there's only one way of doing this now. I thought we could have factored out something, but we can't.